Welcome to Study Loop.
Okay, so this is the free body diagram for the block A. So there are 4 different forces here, which is normal force, the gravity of the block, and the tension from the string, and the static friction. Okay, so since there's angle theta here, so we can decompose the WA, which is the gravity of the block A, into XY component. So WA cosine theta here is the Y component of the WA, and WA sine theta here is the X component of WA. And the black arrow here is the impending motion of block A, okay? So therefore, since we know at these points they are in equilibrium, okay? So therefore, the net force along the x, y direction should be equal to 0. So for the x direction, we have 0 is equal to t plus fs minus wa sin theta. So therefore, wa sin theta is equal to t plus fs. And for fy, we have fy is equal to 0, which is equal to n minus wa cosine theta. So therefore, n is equal to wa cosine theta. And we know the static friction is equal to mu Sn, which is mu S Wa cosine theta. So therefore, Wa sin theta is equal to T plus mu S Wa cosine theta. So eventually have tension T is equal to Wa sin theta minus mu S Wa cosine theta. And this is the free body diagram for block B. So for block B, the situation is a bit complicated here, okay? Because there are 2 friction here. One is the friction between block A and B. Another friction is the friction between block A and the surface. I'm sorry, block B and the surface. Okay. So F1 here is the friction between block B and the surface, and F2 here is the frictions between block A and block B. And T just the tensions from the string, and N is the normal force, and there should be another normal force from the block A to block B, but it's pointing downward perpendicular to the surface, okay, which is NA here. And we know there's angle theta here, so we can always decompose WB. So therefore, we'll have the WB cosine theta as the Y component, and WB sin theta as the X component. And the black arrow here is the impending motion of the block B. So while we know at this point the block B is also in equilibrium, so therefore we have net force along the XY direction should be equal to 0. So we have along the X direction we have 0 is equal to T minus F1 plus F2 plus WB sin theta. So therefore T is equal to F1 plus F2 plus WB sin theta. And on Y direction we have 0 is equal to N minus WB cosine theta plus WB cosine theta. I'm sorry, WA cosine theta plus WB cosine theta. Okay. So therefore, we have N is equal to Wa cosine theta plus Wb cosine theta. And we know F1, which is the friction, the static friction between block B and the surface. So therefore, F1 is equal to mu Sn, which is equal to mu S times Wa cosine theta plus Wb cosine theta. And F2 is the friction between block A and block B, which is mu S Na. Okay, Na is the normal force from the block A. So therefore, we have F2 is equal to mu S Wa cosine theta. So if we plug in back to the equation here, therefore, with the tension T is equal to mu S Wa cosine theta plus Wb cosine theta, and then plus mu S Wa cosine theta, and then plus Wb sin theta. Okay, and if we do some arrangement here, eventually you have T is equal to mu S times 2 Wa cosine theta plus Wb cosine theta, and then plus Wb sin theta. And remember, T can be also equal to Wa sin theta minus mu S Wa cosine theta from the previous case, which is the remember from the free body diagram of the block A. Okay, so therefore we can set Wa sin theta minus mu S Wa cosine theta is equal to mu S 2 Wa cosine theta plus Wb cosine theta, and then plus Wb sin theta. So well, as you can tell, we can divide by tangent theta. Not tangent theta. Divide by cosine theta on each side. Okay, so if we divide by cosine theta on each side, eventually we'll have Wa tangent theta minus mu S Wa is equal to mu S 2 Wa plus Wb plus Wb tangent theta. So therefore tangent theta is equal to mu S times 3 Wa plus Wb over Wa minus Wb. So we know Wa is 50 pound, Wb is 25 pound, and mu S is 0.15. So therefore, tangent theta is equal to 0.15 times 2, not 2, okay, let me see, it's a 3WA, which is 3 times 50 pound plus 25 pound, and then over WA minus WB, which is 50 pound minus 25 pound, and this will give us tangent theta is equal to 1.05. So therefore, we can determine the angle here. So angle theta here should be equal to inverse tangent function of 1.05, which is tangent to the power negative 1, and then what's inside is 1.05. And this will give us the angle is equal to 46.4 degree. And this is the answer for this question.